Hey Netcode Hub channel community, are you tired of juggling multiple API endpoints in your microservices architecture? What if I told you there is a way to streamline your API management, enhance security, and improve performance all at once? Today, we are diving into the world of API gateways, and specifically, we will be using Ocelot to create and configure a powerful gateway for our .NET Web APIs. But before we dive right into this, let's first understand what an API gateway is, and also why Ocelot is a go-to choice for API gateway in .NET environment. Imagine you are managing a growing application with multiple microservices, each with its own API. Without an API gateway, all your clients who will be accessing your app need to know the URLs of each service, handle different authentication mechanisms, and deal with load balancing manually. This complexity can lead to security vulnerabilities, performance issues, and maintenance headaches. Now, let's enter Ocelot. Ocelot simplifies this by providing a single entry point for all APIs, and it can also handle routing, authentication, rate limiting, and load balancing efficiently. It's easy to set up and configure, making it perfect for both beginners and seasoned developers. It also supports a wide range of features like request aggregation, load balancing, rate limiting, authentication, and a lot. It also has a wide range of community support. All this come together to make Ocelot the best choice for microservice. Alright, so now let's jump right into our Visual Studio. We're going to create 3 projects. 2 of them will be sub-APIs. The last one is going to be our gateway, the API gateway. Now, we're going to configure the 2 APIs so that they can be get called through the gateway. So the gateway is going to be like a door to room. Now, it is through the gateway that user can have access to our endpoint or our API that we have in our microservices. Now, click on Create New Project so we can have access to the project template. We're going to create blank solution, then choose location. Now let's create this solution. So let's add the various projects. So we go to solution, right click on the solution name. Then we're going to add new project. And here we need to choose our web API and click on next. But make sure you give it name first. So let's say we're going to have maybe you're going to have a weather forecast and another API known as user. Okay, so this is going to be our weather forecast API. So maybe I can say this is weather API. Then let's create this. So this API is going to perform CRUD on weather forecast. So we can create, read, update, and delete. Let's also add another one which is going to work on user. Maybe we can perform CRUD on user. So new project, the same API. And now here we can say that this is identity. So that's our second API. Now these 2 API come together to form our microservice, but we need to have gateway. So let's create this. And after that, we're going to create our gateway. Our gateway also going to be an API, but in this, we're not going to expose controller. So let's see, let's add the next one. New project. And here, I'm going to say this is gateway. Click on next. So you can see when you check the solution, we have 3 projects in here. We have our 2 APIs and we have our gateway. Now, first thing that we need to do here is when you go to our gateway, we don't want to expose any UI, so I'm going to remove this controller. I'm not mapping any controller, so we can save this. Now the next thing I'm going to do here is let's try to do something small with each API that we have at SAPS. So I need to check the identity from our controller. You can see that we have weather forecast, and I'm going to make this as maybe users. So user controller. And now this user controller, maybe you have these names. Let's say this is netcode. I have the hub, yes, and I have maybe Freddy's here. Let's say this is the list that we have, and as soon as we call this endpoint, it's going to return this. So this is a single or one API which is responsible of performing CRUD on the user. So here we have the users available here. Let's remove all this. And also let's make this as action results. Then return. Okay, let's specify our users in there. Alright, so we're going to return this. API is going to return user. Okay, let's go to the next API, and that is the weather. And you know weather is returning weather, right? Here we want to make it API/user. So API/user. When you go to the weather forecast tool, we're going to do the same. So click on yours and I'll follow along. Yeah, so API/weather forecast. And here we are returning what you see in here, default one. That's what we are returning. Let me get rid of this so that we can have weather forecast, and automatically we're going to have access to this get method. Good. So we have two individual powerful endpoints which will work. Yes, we can try this and see. So let's build solution first. So this is done. Now we can go ahead and now run both. So we have an identity and now weather. Let's start running this weather, and let's also run the identity when this is done. So you can see that we have this weather API, and it is returning weather data, default one. Let's also choose identity, and now let's run this to return the list of users that we have in here. So execute. Now you can see here we have this. So our two APIs are working perfectly here. Now let's go to the Ocelot, and now let's see what we can do to configure our gateway. Let's close this. Now when you go to the solution, to our gateway API, in our program.cs file, maybe let's click on it. We don't want to expose this Swagger, so we can remove this. So let's streamline this, and we are not adding controllers. Okay, the same thing applies to this. Now what we're going to do here is let's go to our packages, dependencies, and you can see that we have the swashbuckler we are not using, so you can remove this package because we don't need the endpoint here. Yeah, so we have a very simple app. Okay, now the next thing we're going to do here is we need to install the Ocelot package. So I click on the dependencies, and now manage NuGet packages, and in here let's search for Ocelot. And that is this. So let's get this package installed. Alright, so now that we have this package installed, I'm going to reboot the whole project again to make sure everything is working as expected. So now we're done with the building. We go to our project. Now we want to have our API or our port in range. So we have 3 project in here. Let's go and specify it. So let's go to, from the gateway, line-setting.json, and then in here we can have access to our API gateways. Okay, that is a port. The gateway here, that is a port. Okay, so you can see from here we are having 7083 and 5175 for HTTP and HTTPS. Now for our gateway, we need to run on HTTPS, but when you have your SAP APIs on a network whereby this network is protected, you can run them on HTTP because there's no external access to these APIs. All client or all requests going to be hit on the gateway. So gateway must run on HTTPS, and the SAPS one can also run on the HTTP. Now let's see what to do from the, this is a gateway, so it is running on 7083. So let's make it 7000. So this is running on 7000 for our port. Now let's go to our identity. From this identity, you can see we have properties folder, line settings. You click on it, and now let's make this for an HTTP to run on 7001. The same thing applies here, 7001. And now you can see it has launch URL to Swagger. Okay, so although we have it here, we can also access it, but for now let's leave the launch URL as Swagger in there, because at least we have this package installed, and as soon as we run, we're going to have the UI so we can check it ourselves. All that you need to do here is to change the application URL, as I've done mine, you to do yours. Good, now let's go and do the same thing to the weather project. We go to the properties folder, and now in here from the line settings for HTTP 7002. Okay, so gateway is 7000, identity is 7001, weather forecast is 7002. So you can see we have this in range from 7000 to 7003. That is what we have as a range of our ports for this microservice that we are creating. Good. So now that we are done with this, we can save this project as well. So as you're done with this, the next thing that you need to do here is you need to specify the up and down. You need to create a ocelot.json file, and that is how we're going to specify all the endpoints in there. So let's go to solution, and in here from this identity, not identity itself, we go to the gateway API, and this file must be in the root. So right click on the API gateway, then click on add, click on new item, and now let's search for JSON. Now we give it a name as ocelot.json. So that is the name that given to this file. Now when we are done, we need to go in there and now specify our upstream path and now the downstream path and other necessary sections that we need to configure. I have already prepared this beforehand because it is too delicate. You can make mistake easily. Alright, so let me just paste from here, then we go through what I have done. Now this it's simple. Yeah, simple. Like see, we're specifying the section of what we have our route, and in the route we are having our downstream path, and now we have the scheme, we have our host and port. So we have three in here, three sections. Now aside from that, you can see we have our upstream path, and now we have the HTTP method. Now this method here tells you which method are going to allow for this address. Now we have our address here, and our host here is the local host since it's running on a local host, and this is our port. So since you're working with the user, we configure the user as 7001, and our the scheme is HTTP. Do you remember we did that? Great. So the upstream path template defines the path pattern that the Ocelot gateway listing for an incoming request. Now there is a URL path the client will use to access the API through the gateway. So that is the upstream path. Now, when you go to the downstream path, it specifies the path on the back-end service. So that is what the Ocelot will use to make a call to that specific endpoint. So the client can access this from the upstream path, and then the Ocelot will use the downstream path to make a request from the API. Okay, so that is one. So you see from here, we have one in here, and that's for API. Then when it comes to our weather, there is also another one. Now, when we are done with this, we need to specify our global configuration, and we need to get the base URL. That is what every user will have to access this. So it's going to be like HTTPS. We have a local host with the port / then the upstream path is what the user is going to access. So it's going to be API/weather, API/user. In case you have more, API plus what you have in there. I hope you've got it right. Great. So now we have this. The next thing we're going to do here is we need to register this Ocelot JSON in the program.cs file. So let's make that happen. So let's go to the gateway program.cs file, and that is this project program.cs file. Maybe we can grab this Ocelot name. Now in here, before the app build, we're going to say that builder.configuration.add.json. Okay, so in here, we need to specify what we copied. That is the file itself. Okay, now after that, this should be a JSON file. So that is the add.json file. And in here, let's set this optional to false. Maybe let's set false in here, and I reload change, let's set it true. So now as we update it, you need to reload it. And in here we need to have comma, then reload, on change, set this to go ahead. Okay, so after we've added this file, we need to add the Ocelot itself. So that is where we need to add the service. So dot add Ocelot. Now maybe we need to add a namespace. Yes, using the reference. And after that, let's come to the middleware pipeline, and we need to use it. So app.use, then Ocelot.wait. Okay. Aside from that, maybe let's add calls here, because since we're going to have a request coming in, going out, well, let's add a call street. So maybe we can add a default policy, okay, whereby we allow any origin, any method, and any header, because at the end we want to perform CRUD, so it means we want to allow any method. But in case you want to specify specific headers or HTTP verbs, or within the CRUD a specific endpoint, then you can specify that in here. But for now, let's allow any method at all. Alright, so let's have our builder.services.add calls. Then in here, let's give it as option. And now with this options.add, we have default policy. So now with this default policy, let's have builder. Then in our builder, we say builder.allow any header first, dot allow any method, then we can allow any origin. That will be any address coming in. Okay, now let's terminate this, and we need to use this call. So app.use call. Alright, let's terminate this. Great. So now that we are done with this, let's build up together. Now let's set a default landing page, or is it landing URL? Check it out from the properties, launch settings, and you know from our HTTPS, not the HTTP, because there is a gateway and it is running on HTTPS. We are saying to land on Swagger, but we do not have Swagger available. So this is what we're going to do. We want to make it API, or maybe we can make this empty. Okay, so it's going to land on localhost and now the port of 7000. All right, so let's see. Now let's run the 3 projects. So you know this is running on HTTPS, so maybe let's start with the other ones on HTTP. So let's choose identity is running on HTTP, and also weather is running on HTTP, right? Okay, so in here identity, and now let's start new instance. Alright, so you can see that here it is running on port of 7001, and that is identity. And you know what to do. We get our users, and wow, we get them. Good. Now let's see from the other one as well, and that is the weather. So right click on this, let's also start, and we are expecting of a port of 7002. Now debug, and now let's start new instance as well. Now this is almost ready to, you see the 7002, good, so our ports are in line. And now let's try to get this, and well, we have the content here. Now let's run the API, the gateway, that is the heart of this video. So I click on this, and that's going to be debug, start new instance. And you can see, since we have this does not land on any page, we have this local host page can be found. So this is our gateway. Now with this gateway, if I click on this API, remember that is the upstream, so when you check from the Ocelot, we have the upstream, that's a local host with the port slash the upstream, that is an API slash with a forecast. So they can grab this. Now let's go to, let's check for, now let's space it. Let's see whether we're going to get the data for the weather forecast. Alright, so we are not having it. Let's try user with the same port. And great, yeah, we have user. So you can see we have the user. Let's see, is it weather forecast or weather? When you check the controller, oh, that's weather forecast. Wow. Then let's correct it. So that's a weather forecast. And now let's check it out. Okay, yeah, still not having this weather forecast. Let's go and check API, and the controller name is weather forecast. That is a get API, and we're not getting it. Yeah, I think I am getting the issue. When you check the configuration, you know, this is our weather forecast. We made it as weather. Great. You know, we made a mistake in here. I believe you've done the correct thing, right? That's great. Okay, so now we have this. We can go ahead and I'll run the, let's stop everything and run them again. So now that we know our identity is working, we are not going to run that. So let's run the weather forecast and then the API gateway. So our weather is active. Let's go to the gateway. Alright, so now let's try to access it, and I believe you still remember the address, right? So that is the endpoint is /API. Then we're going to have our weather forecast. Now let's try and see whether we're going to have it. And great, we have it. Can you see it? Good. We are taking it a step further by ensuring that each web API in a microservice architecture listens only to the API gateway. This means we will configure our services to reject any API call coming from outside the gateway address and port. This setup is crucial for maintaining a secure and efficient microservice environment. You know, in microservice architecture, having a centralized API gateway like Ocelot helps manage and route requests efficiently. However, it is vital to ensure that all external traffic goes through this gateway. Allowing direct access to individual service that you have in your microservice can lead to security vulnerabilities, inconsistent traffic handling, and potential misuse of resources. By restricting access to each service and ensuring they only accept requests from the API gateway, we can ensure or we can enhance security by preventing unauthorized access and potential attacks on individual services. Aside from that, we can also simplify traffic management by ensuring all traffic policies, such as rate limiting and load balancing, we can apply them consistently. And also, we can maintain security integrity by protecting services from being overwhelmed by direct requests, which could bypass essential gateway level controls, such as authentication and authorization. So, implementing a restriction for APIs or services in microservice to listen to only the API gateway is very important. Now let's dive in and see why this is important and how we can implement this. So if you're able to watch the previous video, that is where we created our microservices. Now in that we created a solution and added 3 projects. They are all web APIs. Now in order to add the API or the gateway, we added 1 project, the same web API, but this is known as the gateway. We did not allow, we did not issue the middleware of controller. So this is not having a viewpoint or a controller access point. Since it is a gateway, it needs to connect all the other microservices or all the other APIs or services within a microservice so that it can connect to each, and now any request that comes in from a client will pass through the gateway API, then it goes to the specific endpoint or the service. So for me to go through with it, if you haven't checked it out, I'll put the link in this video description. You can check that one out. Well, if you also have a microservice that you can follow along whilst we try to implement this restriction on this microservice. So we created a solution. You can see we have 3 projects in here. And what we did here was quite simple. From the controller to this, we had this gateway, and then we have identity API, and then we had weather API. Identity API has only a method, and this method returns, or endpoint returns, a list of users. When you go to weather controller 2, it also has a weather forecast controller which returns the weather data as default. We did not do much, but let's say this, when we make a call to this, the following endpoint, we need to retrieve what we have set in here. Okay, and we don't want this to be accessed direct. We want this to be accessed through the API gateway. So in that, we created another API, and I will name it as a gateway, whereby we install the Ocelot package as a NuGet. Then we configure the Ocelot.json. That's where we need to specify our downstream path and the upstream path, and the host and the port. And as I speak, this is working. We can get data from these various services through this gateway. Now let's try this and see. So the API gateway is running on the HTTPS, and the others are running on HTTP. So let me this is a gateway. It's running on HTTPS. So I'm going to right click on weather, then debug this, start new instance, and I'll do same to the identity, and also start new instance. And now we have our API gateway, also start new instance. Yes, so you can see that all these controllers, all these projects are running, and we have it. So this is our gateway. Since we did not map controllers, we are not seeing any view. We don't have Swagger as well. So this is what we have for our gateway. And now when you go to the next one, you can see we have our this identity endpoint, a controller, or maybe the project, and you can see we have our weather controller as well. Good. Now if I click on this, you know, this can return a list of users, and that is what you have in here. And now this can also return a list of weather forecast, but we don't want this to happen. You know, here we are having a direct access with the port of 7001, and now this also with the port of 7002. Now we can also access the same endpoint from here. Now this is our API gateway, which has a universal port that is 7000, and now in that, in order for us to access the user, we need to have /API and now user endpoint. Now this will give us the list of users. So let's wait and see. Yes, we have the list of users in here, and that is this one. The same thing applies to, we can get a list of weather data as well. So when you open a new tab and now we paste this, we change this to weather forecast. This is also going to return weather forecast data for us. So you can see that they are having the port of 7000 and 7000, right? So we are able to access this endpoint through our gateway API. But the problem is we don't want to have a direct access to this, because in this we may implement authentication, authorization, rate limiting, and other features to this, which will handle all requests that come in. But with this, we are not implementing any of them on each of the service in here. So how do we make this service private? How do you make this service reject all direct calls, which is having from the port of 7002 or 7001, and listen to only 700? How do we do it? We can implement this in two ways. First way is using we can set firewall so it can reject all calls and now listen to only call with a 7000. But if in case the environment changes, then you need to also set the same firewall in there, right? Now we can also implement middleware. So middleware is going to add maybe a feature to any request, and that's going to be for verification. As soon as it gets to the client here, this client will verify, is this request coming from the gateway? If yes, then it can give this request green light. But if no, then it's going to reject it. I think this is a suitable way that we can handle that. So let's see how we can do same. So let's close all this. Okay, so this is our project. And now in here, what we're going to do here is we need to create middleware. Now we're going to create two middlewares. The first middleware is going to be in the gateway. Now as soon as the gateway receives any request, it's going to access the header and I'll add a specific content to the header. That is a request header before it pushes it to the service. As soon as it gets to the service, we're also going to create another middleware which is going to access a specific header that the gateway set. As soon as it gets it, then it can verify that yes, this request has passed through the gateway, and therefore I can go ahead and process this. I hope you've understood the scenario. Good, that is what we're going to do. So let's go to our gateway API. Now let's right click on this. We're going to let's add a folder to this. And let's say this folder is middleware. So all middlewares are going to be kept here. Now let's add a class. And now maybe I can give the name of this as interception middleware, because this is going to intercept all requests and now modify the request before pushing it to the various services. So let's give this as intersection middleware. Now once I have this, or we have this middleware created, this needs to pass in the payload of a request delegate. So request delegate. Now let's make it as nest. So in here, let's have the method. So public async task, and that is invoke async. This takes in HTTP context. Let me say this is context. Alright, so in here, this is what we're going to do. It's very simple. A line will make this happen. So let's say this context that we have in here, dot request, that is coming in. That is coming in from the user. So dot request, that is coming from the user, dot headers. And now this headers, we want to modify this. So let's say this is referrer. So this referrer, meaning this is going to refer to a service. Now within this, we want to have access to maybe API gateway. So it means when we get to the service or the sub, we're going to check, does the request have a referrer? If yes, it has a referrer, meaning it has passed through the gateway. Now so after we have this, I wait that we can call next, execute the next middleware. Let's pass in the content that we have modified, and that is all. So when we have the next thing that we need to do here is copy this. Let's go in and register this middleware in the program.cs file. So in here, we're going to be using app.use middleware, and now let's pass in the middleware that we have created, terminated. We need to include the reference. So let's make sure we have the reference also included. And that is using gateway middleware. Great. So now we have this set. So all requests are going to be intercepted and now modified. Let's go to the various services. Now you can see that from here, if you decide to create a middleware for each, it means when you scale up your microservice by adding multiple or more services, you have to copy the same service and be pasting it in the various services. So in order for us to make this, in order for us to skip repeating code, we can add a class library where we're going to create a middleware in it. And now any project that we add, we can just go ahead and add this library. Sounds good, right? So let's do that. So let's go to solution. We add a new project. And now here, choose C# or class library. And now here, I'm going to make it as shared library. So shared library. And that is the name for this project. .NET 8 framework, and of course, let's get this project created. So once we have this project added, this is going to give us a default class. It comes in with the creation of a new project. So with this, maybe we can just rename this, and I'm giving the name of maybe restrict access middleware. Well, you can also give it a name of your choice. So let me have a restrict access middleware. Maybe we can put this in the folder, but since we have only one here, that's the reason why I'm not putting it in the folder. Okay. Now we need to also use the same thing. This has to take a request delegate. So request delegate. So request delegate. And on this request delegate, in order for this to work, we need to install a package That is a Microsoft.ASP.NET Core.http.abstraction. So let's install this, find and install the latest. So we have this package installed, and now this is going to execute the Nest middleware. Let's give it as Nest. And as you know, we need to create a method, and this is going to be a public async task, and that is invoke async. And this takes in HTTP context. So HTTP context, and we say this is contest. Okay, so the next thing that we're going to do here is quite simple. Let's get the referrer. So referrer equal to, then we can extract this from the context, then request dot headers. And now this headers, we know there's in case this request was issued by the gateway, it will definitely have referrer. So we can grab this, then we say grab first or default. Then we can now make a check. So if we have a string here, string dot is null or empty, then we're going to check the referrer. If this is empty, it means this request is not coming from the gateway. It is an external or direct request coming from harmful client. Then what can we do? Let's have context.response, then .response.status code. We can set this to status code. We have this dot, and then maybe 403. So we can use that. Okay, so let's say status 403. 403 forbidden. And aside from that, we can have await context dot response dot, let's have a write async. Let's give this user some message. Maybe can't find something like that, or unauthorized, whatever that you want to give it to, he can give it. Okay, so I want to display can't find this page. Yes, or can't reach. I think I'll make it as reach, or you're not authorized. When we are done, the next thing is return. So this is going to intercept, and this is going to kill this request. So the next middleware won't get executed. Now this is going to return it with this error message. Good. So now that we have this, we can terminate this. Great. Now, but in case it isn't, then we can have else. Then what we do, let's say await. We have our nest, and I'll pass in the context. Let's grab this. Then, in order for us to use this middleware, what must we do? I believe you know, isn't it? Great. So you have to add the reference. So we need to add it to the weather forecast, right? So I click on dependencies, then shared library, select that, click on OK. The same thing applies to the identity, dependencies, project reference, then add it. Now let's include them in the various program files. So in here, what we're going to do in here is we need to use, maybe on top of the controller, we say app.use middleware. Then let's include this middleware. That's a request restrict access middleware. Oh, it shouldn't be here. Rather. Okay, so let's grab this. Let's go to the identity program.cs file, and in here we paste it there, and that is all. Let's build the project together. Now let's start this project and test it out. That's great. 4 succeeded. So let's go and start our microservices. We're gonna have our first gateway, so we can start our gateway. Let's start also the identity. Then lastly, weather. So our microservice is ready. Now this is the weather. We have it here. Great. Then we have the identity in here. Then we have, that is the gateway. Let's try to access this directly and see. So if I click on, try this out, execute, the response here is what? Forbidden. That is forbidden. You see this? Forbidden. Now let's see, in case we decide to run this, and I say this API/user, that's what's going to happen. So you can see, can't reach this page, right? So on the UI, we have forbidden as 403. And now, when you check it, direct access from here too, we have can't reach this page. Although this page is live, but we cannot reach it because the middleware has taken charge, and now it is doing magic. Let's use him to the weather forecast and check it out. Execute. The same forbidden. Let's grab this. Open a new tab. Then we're going to say API/weather forecast. Now let's test this out. The same thing. Hope you are getting it. Now once we have the same can't reach this page, let's go to the gateway. Now in here, we want to access the user. Check it out. Great, now you have the user from here. Do you see it? Let's grab the same, open new tab, and now instead of user, it's going to be what? Good, weather forecast, isn't it? Test it out, and now we have it. So we've able to achieve this, right? Now you cannot directly access the various services unless you pass through the API gateway. You now have a robust setup where each of your microservices communicate exclusively through the API gateway. Note, this approach is not only fortifies the security of your architecture, but also ensures a more streamlined and manageable traffic flow. We are diving into an essential aspect of securing our microservices architecture, and that is adding JWT authentication to our microservices that use Ocelot as an API gateway. If you have been following along, you know we've already created our microservices and set up Ocelot to redirect all API calls seamlessly. Now is a time to add an extra layer of security. Imagine a scenario where your microservices handle sensitive data, such as user information or financial transactions. Without proper authentication, anyone could access your services, potentially leading to data breaches and unauthorized access. That is where JWT, that is JSON Web Token, authentication comes in. JWT provides a compact and secure way to transmit information between parties as a JSON object. By adding JWT authentication to our API gateway, we can ensure that only authenticated and authorized users can access our microservices. So in this video, I'll walk you through the step-by-step process of implementing JWT authentication in our Ocelot API gateway, ensuring that each microservice request is authenticated. So let's get started and secure our microservices like a pro. So in the previous video, this is what we have been doing. If you haven't checked any of the videos out, you can check the video description. I have the links in there. We've created projects in here. As you can see, we have 4 projects, 1 as a library, 3 as APIs. Within that, we have 1 as a gateway, and also we have the 2 as services in there. These make up our microservice. Okay. So in the gateway, we installed the Ocelot package, and we've configured the service in as a route by creating an ocelot.json file and specifying the route in here. Currently, we have 2 endpoints or 2 services. So we have 2 services or 2 routes also specified, and that is the API/user, and also we have an API/weather forecast. Aside from that, we created a base URL which will be accessed by the client, and then we have our upstream which also will be accessed by the client, and we have a downstream which is going to be accessed by the Ocelot API gateway. All right. So if you want to actually understand this well, check the video description and now watch the previous videos. Good. Now let's go and add authentication. There are several ways of adding authentication to this. By this project, I'm going to create a separate project which will handle authentication in our microservices. So before we dive right into that, I have already launched this for you to see what is going on. Let's see, I have this created. Okay, so this is what we did previously. I'm just trying to show you where we are. Now you can see from here we have weather forecast. This is our weather API. This is our user API. Now we cannot directly access this endpoint. You cannot do that. You're going to have forbidden. But you can access it through the gateway, the API gateway. You have forbidden. But here you can access it with the default port of 7000. And in here we're going to have 7000/API. Then you're going to have user. So that is the route for this user, and you can see we have the user in here. Aside from that, you can also access the same route and now get the weather forecast. So by making it API, then we have our weather forecast, and you can also get this weather forecast record or data. So you can see that this was configured in the previous video. Now you know how we can restrict all requests and then direct all requests through the API gateway. All right. Now, in order for us to authentication, let's add separate project. So I'm going to add another project to this. So right click on solution, then let's add a new project. And now this is going to be an API as well. So we choose the ASP.NET Core Web API. And now this is authentication. Authentication API. Now let's click on create. And in here we need to add this to the project. So let's do that. After we have this project created and been added, you can see we have it in here, authentication API. Right click on dependencies and let's install a NuGet package, which will be useful in the authentication creation. So let's have Microsoft.ASP.NET Core.authentication.gwt bearer, and make sure you install this package to the project. So now that this has been installed successfully, you can cross-check from dependencies, packages, and you see it over here. Great. Now when you go to program.cs file, you can see we have this in here, but let's install Swagger as well. So if you don't have that, I don't have it, so I have to install. Let's install ASP.NET Core. So the same place, and now think Swagger. So that is a swashbuckle.asp.NET Core. Let's install this package as well. So after we are done, we go to the program. Now let's add the service in here. So we're gonna have builder.services .add swagger gen. Then as we are done with this, we need to add the pipeline. So what we have in here, we can check if the environment is under development, we can add that, but for now we can skip that. Or maybe we can bring it. So app dot, then we're gonna have environment dot is development. Then what are we going to do? That is where you want to introduce use a swagger. So, and also use swagger UI. Good. So we have our swagger integrated successfully. So let's go to our solution, and I can see from here, let's check the Ocelot, the port for each of the API that we created already. Now when you go to, that's the gateway ocelot.json, you can see that you have from the user it is 7001 for the port. Now weather forecast 7002, and now from the gateway it is 7000. So we can make the authentication here as 7003, right? And this should be in an HTTP. So let's go to authentication, properties, line setting.json, and now where we have this, the profiles, where we have this HTTP, we're going to make this as 7003. I think so. So that's 7003. And then we have 7001, 702, and then 703. So we need to also make it 7003. Great. So now that we are done, we need to go back again and now add our JWT configuration. So let's add a service in here. And there's going to be builder.services .add authentication. And now this authentication, we need to specify our JWT bearer. So with this, that is a bearer default. And we need to use the namespace. So .authentication scheme. And after that, let's add JWT bearer. You can give it a name, but let's skip that. So option maps to, we need to have it in this. All right, so in here, let's grab our key first. So key, we're going to use encoding. Now this encoding is coming from system.test. And now with this, we have our key. But before we do this, we have to first set the key first. So let's go to the app setting.json, and that is where we need to set our key. Let's app setting.json in here. Good. And now let's have a section known as authentication. Then we need to specify our key. So now this key, I have a key here. It should be more than 16. So let me grab my key. And aside from that, we need to specify our issuer. So at times with the issuer, we can skip that. But let's set it. So with the issuer, there is an HTTP because you want to use an HTTP of this, and I will set it localhost. The port is 7003. I think so. When you cross check from the Ocelot, we have 7003, so it means the API or the authentication will be 7003. Check the line settings from the HTTP, it is 7003. Great. Then let's have the audience. So we can make a copy of this, and I'll set this to audience. And it is the same. Alright, so now we have this. We want to grab our key, and that's what we're going to use. So in our program.cs, let's get it in here. Now we need to use encoding.utf8, and in that we want to get byte out of it. Which are you talking about? Talking about this builder.configuration dot we can use get section in here, and now let's specify section as authentication, then key, and in that you want to grab 8 value. This could be null, so let's check it. Okay, so authentication, we have location. Yes, so that is authentication and now the key, and that is what you want to grab, authentication and now this key. Great. So we have our key in here. The next thing that we're going to do here is we can actually state our issuer and audience. So let's have string. We say this is issuer. Now this is builder.configuration. So, and now with this configuration, we can even set authentication. Then we can grab the issuer. And now we can also do same to the audience. Okay. So let's start setting up this. So we're going to say there's an options dot required metadata. Let's set this to false. So from that, we're going to say options dot save token. Let's set this to true. Options dot, so token handler, or that's a token validation parameters. We have to set its new instance, and now within that we need to specify, let's say validate issuer. This is true. Then let's have validate audience to, set this to true. So from that, this is validate. Okay, now let's set validate lifetime. So with the lifetime, we are not having a refresh token yet, so let's set this to false. So our token never expires, so false. Then validate issuer sign-in key, we have it in here. So validate issuer sign-in key, set this to true, and let's have a valid audience and now valid issuer. So valid issuer is equal to the issuer that we have, and valid audience is equal to the audience that we have as well. And the last one, let's specify the issuer sign key, and that's equal to new symmetrical symmetric security key. So symmetric security key, I think new. So we can get it from here, and now let's pass in the key that we have from our app settings, and that is this key. Okay, so we have the settings being set up. Now we need to add calls, because we're going to make an endpoint call to this. So we need to activate the call. Let's do it straight. So let's have a builder.services. Whoa. So builder.services.add calls. Then with this calls, we can specify an option. Now we say this options.add default policy. Now on this policy, maybe you can have a builder Then we have this builder dot allow any header dot allow any method, then dot allow any origin. That is what we want. So when we are done, let's register this. So app dot use course. Okay, so we have this set. Now let's go in and create our controller. So we're going to do everything in the controller. We are not actually going to connect to database. We're going to create concurrent dictionary, which takes in username and password. And we're going to keep that as a temporary data for now. So let's go to our controller. And now in here, in the authentication endpoint or the authentication project, we go to this controller. And this controller, maybe we can, let's change this to accounts. So account controller. And let's remove all this. So this is going to be an async task, and let's make it as I action results. And that is account. So for the route, it is API account. Okay, so maybe we can have a wait task.delay. Let's delay this by 500 milliseconds. And aside from that, let's create a private variable to handle the list of users in here. So this is going to be private static. And let's use concurrent dictionary. So we have concurrent dictionary, which takes in string and now string. And now so this is user data. We have our get and set. And now this is equal to new of this. So this is what we're going to use to hold the data. Okay. Now the first here, we're going to have the login, maybe register. So let's have a login. That's HTTP post. Now with this post, we're going to say this is login. That is a route. So here the route is going to be API/account. Then we have our login. Okay, then in here we're going to be using parameters. So we need a username, or let's say email. Then we're going to have password. So this is what's going to be for the route here. So login. Now since there's going to be post, let's specify our string. That's our email, and we have our string, and that can be our password. All right, so in here, what are we going to do? Let's first get the email from the list here. Let's check if the user is already in here. So we're going to say this is get email. Then we can say that is user data. We can have keys in there. And maybe we can use first or default or where. Then in here, we're going to say this email is equal to the email coming in. Okay. Now, aside from that, what are we doing? We can get that first or default. So we have it in here. Now let's check. So we say that if this string in here, so let's say if this string dot is null or empty, let's specify our get email in there. So if this is empty, that is where you want to, if it is not empty, yes, that is where you want to handle this. But in case it is empty, then what are you going to do? We can return not found. That is all. Okay. So maybe can we pass in email not found? Maybe we can customize the message in here. And aside from that, in case it is we find it, then let's check if the password the user is providing is equal to what we have in this data or in this list. So how are you going to do it? we're going to use this user data. Since it's a dictionary, we can grab it, we can compare it straight away, and now move on. So we can tell that this is try get value, and on this try get value, we want to specify the get email that is coming as a key, and now we're going to have an out variable. Now this is going to be the password. So this out, this could be string. Let's specify that. Now so this is password, or maybe I can say this is db password. Okay. So in case we get it, keep it in here. Now the next thing to do here is we're going to check. So if you're going to say this is not equal, and now this you want to specify db password, and also we're going to specify the passwords coming in. If it is not equal, then what I'm going to do, we want to return bad request. So maybe we can say something like invalid credentials. Well, we can pass something like that. But in case it is valid, then what are we going to do? We want to have a method that is JWT token, and this method is going to generate it. So this is generate token. Now let's specify the email. So that is get email. So we need to then create this method. Then after that, we can return OK with this JWT token in there, and now we are done. So let's create this method. Control period. Let's generate a method for that, and that is a generate token. So in our token formation, we need the key as well. So let's inject iConfiguration. Then we say this config. Then in here, maybe we can have a look at. We can say this is key is equal to config. Then let's specify the authentication, and now the key. So we have our key in here. Now let's have our security key. So the security key here, but before we get this key, I think this key we have to get encoded. So you can grab this, and I will say this is encoding .utf8.getByte. Then let's paste in like that. Let's make it check for now. Okay, so let's have a security key, and this is going to be new symmetric security key. Now let's specify the key that we have in there. So from that, we need to create credential. So with this credential, it's going to be new sign-in credential, and now in that we need a security key. This is a security key that we have. So let's paste in this, and need the algorithm, security algorithm. So security algorithm that we can have. Let's use the HMAC256. Okay, then let's have our claims. Now this claim, since we have only the email, we're going to set only email as a claim. So in here we're going to have new claim, and now here we need to specify claim type dot email, and what is the value? Get email. That's all we need to do. Okay, so once you have this, now let's get our token, and now this equal to new JWT token, security token, and now in that let's specify issuer here it is config, then we can have authentication dot issuer authentication, then we have our issuer, then we need to specify audience as well, and the same config. We have authentication, then we have audience, then what do you need again? We need our claims. So in our claims, we have the claims created already, and the next thing that we need here is an expiry. So this is going to be null because we are not having any expiration time in here. And the next one, let's have our signing key, signing credentials, and in here we have our credentials in there. So after we have this, the next thing is to return new JWT security token handler. The new JWT security token handler. And now in this handler, we're going to write the token and now pass in this token. So this is going to be a string because this write token returns string, and now I return it in here. Great. Now we have this set. Let's add, that is HTTP post. And now here we say this is register, and we have our public async task, and that is an iAction result. So we say this is register, which takes in string email and takes in string of what? Password. Then what are we doing? Before we move on, we should not forget this needs email and it needs password. We need to do the same thing here. So that is email and password. Okay, and these are the variable that we are passing them here as payload. Great. Okay, so register, what are we doing first? Let's have our await tags delay store 500 is what we need. Then let's get the same email. It's equal to user data dot keys dot first or default, and now in here we specify. Okay. Alright, so this is going to give us the first one, but we don't want the first one. What I want to do here is you want to look through and now select what we need. So it's equal to this email. Okay, now we are saying that if we have this as string that is null or empty, let's have our get email. If this is empty, then return maybe bad request, and maybe we can say that invalid because here we haven't registered, so this is not now. User already exists. Yes, so user already and now exist. Okay, but in case it is not found, then we're gonna say that user data, we can have a look at this, and instead of we can specify the email, that is the key that we set, and now the value is equal to password, and after that you want to return okay, and now say user created. Okay, so that's what we have. This is going to be our login and our register endpoint. Our login is going to return the token as soon as we are done. Great. So let's try only this, the endpoint, and let's check this out. This should run on HTTP. That is 7003. Let's wait and see. Alright, so this is ready, but I can see it is not locating to the Swagger. So maybe let's Swagger in there. And yes, we have the Swagger, so we're going to configure that. Now in here, let's try to register. You pass in user to example and password. Execute this, and you can see user created. Let's log in and see whether you're going to return the token. And now let's execute this, and now you have the token. So you can grab this token, then go to jwt.io. Let's see that. So jwt.io, and let's verify the token that we have. So we see this algorithm, this is the type, and there is the claims. We have only one for email, and there is a issue and the audience. There's no expiring dates. Okay, so this is working. Now, in order for us to have a launch and straight ahead punch Swagger, we go to our launch settings, and in there you can see it is weather forecast. So change this to Swagger. And that is all. So the next thing to do here is, how do you restrict this? Now, you don't want people or clients to have direct access as what you've been doing to the other services. So in order to do that, we need to inject, or you need to include the library that we created, which contains a middleware which intercept requests and verify if it is coming from the gateway by checking a header, a specific header known as a referrer. So we need to do that. Let's see. So from our authentication API, right click on dependencies, then add project references. In here because we have a shared library, so let's add this. And in there, let's go to the program.ts, and now where we have this, we need to add here. So we say app.use middleware, and now this middleware, it is known as, is it redirection? Wow. So let's go to our shell library, and that is a restrict access middleware. So in there, we're going to paste it in here. Yes, so if you don't know what it's doing, we created this middleware in the previous video. What it's going to do here is any request that comes in, is going to check this from the other services. It's going to check if it has a referrer which will be added through the gateway. In case it does it, then it does have, then it's going to continue on. But in case it doesn't have, then it's going to stop it. It's going to kill the request. You see? So any request that comes in must be first intercepted by the API gateway, and now within that interception is going to add a referrer header to the request. Now when it comes in, we also verify from the client, and I'm making sure this request is coming from the gateway, but rather not from any direct client. Great. So now this is going to work. Now when you run this again, if I try to register or log in, I'm going to have 403. That is forbidden. Let's wait and check it out. So quickly, let's try to log in. Okay, we need to register first, right? So let's see from a registration. Try this out, specify defaults, and I click on, you can see we have forbidden 403. And now when we put breakpoint at where we have, if I put breakpoint here, you can see that this will be hit and this is going to be null. And that's the reason why we have that. Click on this, and this is hit. Check this. That is null. Good. So this is working. Alright, so now that we have this, what is the next thing that we need to do? Let's go in there and configure the upstream and our downstream in the ocelot.json file that we created. So we want to specify the route. Let's go to solution, go to your gateway, and on the ocelot file that we have in here, we need to make a copy of this, and now we're going to paste it in here. So you have to bring comma, then let's paste it. So you can see from here we are having an API and the controller name is account. If you cross-check from here, you can see we have an API account, the name login, and now this what we have parameters here as 2 parameters, and that's what we are doing in here. So API account, and I was going to take in the first one is an email, and I'm taking the password. This is an HTTP, and that is a port of 500. So this is 7003. And aside from that, you have the same thing in here. So we have a downstream which is going to be accessed through the Ocelot API or the Gateway API to this service itself. And now here is what the client is going to access with the help of this base address and now this specific route. So the user can get access to this by performing any of these method. So get, post, put, or delete. Okay, so now that we have this running on HTTP, we can save this peacefully. So the last thing that you want to do here is you want to create a middleware to intercept the request and now check if the user is authenticated. Now, if the user wants to register or log in, we don't want to check authentication state of that user. But as soon as the user wants to access a weather forecast API or the user API, this user must be authenticated. So you can see in our project, we have 2 projects added. That's an API or 2 services added. Now in each, we have the weather forecast controller and we have user controller, right? From the identity, we have user controller. Now before user or client access any of these methods, this client must be authenticated. And we can handle that by using a middleware to check it. Bear in mind that we normally intercept the request, then we can now check and now kill the request or push the request. So let's do that. Now in our gateway, you see we have a middleware folder. Let's add another folder to that. And with this, maybe we can name this as token checker middleware. That's the name that I'm giving to this. So token checker middleware. Okay, and that is the name. So with this middleware, it's going to take in request delegate as usual. So it takes in request delegate, and now we say this is next, which needs to execute the next line of action. Then we have our public async, and this must be a task, and it is invoke async, which takes in HTTP context, and now say this is context. Now in that, we want to get the path, so we can this is request path, and this equal to, we can extract it from this context dot request dot path dot value. So we can get it from here. And now let's have a look. Let's check. So we say that if request path, let's check for nullability. And now if request path that we have in here dot contains, and now what are you going to check? In case it contains something like account, that's an API / endpoint as login, then we want to leave it. And now we can have string comparison that variant culture ignore case, and also we can let's make a copy of this, or in case it contains account, or in case it is equal to the home. So in case, so request path dot equals to this home, then we want to remove this first. Okay, then we want to forward it. So await, we have next, and I execute the next middleware. But in case it isn't, then what are you going to do? In case the URL does not contain any of this, then you want to check, you want to grab the authentication header. So we can say this is auth header. Then we say it is context. Now instead of having it, we can just straight ahead, we can say request dot headers. Then we can get authorization. So you can get this. Now let's check. So if this auth header dot first or default is equal to null, then what are we going to do? We want to have our context dot response dot status code. Whoa. So we have our context dot response dot status code, and we set this to status codes dot, and maybe we need to use 401, that is unauthorized, right? And after that, let's have await context dot response dot write async, and we can say that sorry, access denied. Here we can have else await next, and let's specify in the context. So that's all that we need to do in here. Now we want to check if the path here contains either any of these. That means you want to, the person going to register or is going to log in. If so, then grant it. But in case it isn't, then go and check if you can have a section known as the header known as authorization. In case you do have, then continue. In case you don't, then return this. So you can see here we are not actually verifying. So we are not checking for rows. We are not actually verifying if the header fits or if the header is what we need. All that you need to do here is we are just checking if it contains authorization header. So we can go beyond this, but for now let's maintain this and make sure that this works and secure our system. Right, so now that we have this, let's copy this. Let's go to our gateway program.cs. So our gateway program.cs, and now where we have this interception middleware added, we can make a copy of this. Now this should come first before this interception middleware, because this is going to work and check if user is authenticated. Then you're going to check in case it is login or register, then this interception will just intercept it and now append the header section to it and now push it to the next middleware. Alright, so that's all we need to do to make this system work. Let's run the whole project and then check it out. So this authentication, now right click on debug. Let's start this instance. Let's also check. Okay, let's do it again, or let's rebuild this project once more. That is built, so right click. Let's go to authentication. Now let's start this. Let's make sure this is set to HTTP. Then start new instance. And when this gets started, we are also going to start our API gateway. Let's also start this. Then we're going to start the identity as well. Start. Now let's start the weather API. Alright, so you can see that our endpoints are ready. Now if I click on weather forecast, try this out. Because I have 403 forbidden. The same thing applies to if I want to create an account. I must see the same thing because the middleware is working. Yes, and for identity too. this API. If I call this, I have the same forbidden. Alright, now let's try to call them here and check it out. So first of all, we're going to call our API/user, and we must have the user data. So this is also access denied, because here we are not authorized, right? So how do you authorize? I have a postman in here, and that's what you're going to use to work. Now before that, we need to create an account first. So how do you create an account? We have this, and now the port here, it is 7,000. Okay, now it's going to an API account login, and now we have user at example.com with the password. It is post. So if I click on send, let's see what's going to happen. So we can put a breakpoint here from the account, or we can even put it from the middleware that we have created. So with this, it's going to now check. So as soon as I hit on this, it tells you that that endpoint is coming from any of this. Now let's put a breakpoint. Let's hit it. So if I click on send, let's see, now breakpoint is hit. Now you can see the request path here has an API account login. So it means it's going to go to the next line of action. And as soon as I on it, let's see what we get. Okay, so email not found, right? Because this is login. So this is working. Now let's change this to register. And I'll click on send. And I can see, okay, so sorry, access denied. This is register. This is post. Click on send. Access denied. Let's put breakpoint. Now let's send. Okay, so I want to check the path. It is API account register. Do you have it here? Okay, so you have an account. Alright, so let's continue. And I can see that you have user created successfully. You can also add another one. So this is, you can just add user 1. Then click on send. Now let's wait and see. Breakpoint is hit. Request, and now it is this user 1. And now let's see, so you have it in here. If I click on step out, you see it's going to execute this. Yes. And now this is also created. So let's see. We are waiting for the response. And now we have this user also created. Now let's go to login. So if I try to log in, or maybe let's try to access the API, this user. We have created an account. We haven't logged in to have our authentication JWT token, and we are trying to access this. So the general port, the gateway port is 7000. Click on it is get. Click on send. I must have access denied. So you can see that I'm having status code of 401 unauthorized. If I go to weather forecast, let's see. Click on send. I have the same thing. Now let's log in and check it out. So from here, I have this 7000, and now it is a username and password. So you're going to log in. There's no more register because you have an account already, and that is login. Let's see whether we're going to have a token. Okay, so this email not found. Alright, so we just started, so you have to create. Let's say this is register, send, email created successfully. Now let's log in. Now you must have a token, and great, you have it. So let's go and copy this token. And now for us to make another request, let's say the user request, whereby if I click on get now, it's going to provide access denied, which is 401. Let's go to the header. And now this header, let's add authorization header. That is a key. And now let's add the value. So we have to type in bearer space and now paste in the number or the token in there. Then after we're done with that, let's make a send and let's check it out. So you can see now we have it, right? So if I go to the header, there's a header that came, okay? So there's a body as well. So now you can see that after we've added that token, now we can make a request in here. Now if I change this to weather forecast and try to make a send, we're gonna have the record in here. As you can see, we have it because now our request has token. In order to verify, maybe we can put breakpoint at where, let's say weather forecast. So we have a checker. Maybe let's check from the shared library. This shared library contains this restrict access, and that is going to make a check here and check if it has referrer. Well, it's going to have it. Let's go to the token checker from our gateway, and now here it's going to check whether it has token from here. So let's put a breakpoint, and now let's go to our postman. Since we have the token added, click on send. It's going to get hit. And if I click, you can see we have the token over here. And as soon as we have the token, we can go ahead and execute this. So you can see this token, we are not doing anything. We are not checking this token. We are not verifying. We're not doing anything. All that you are checking here is to check if it has a token, give it green light. Maybe you can go beyond this. You can go further by extracting even claims from this when you add claims. And now based on the claim that the user has, you can allow the user on a specific endpoint and more. All right. So we have successfully added JWT authentication to our microservices architecture using the Ocelot as our API gateway. So by doing this, we have significantly enhanced the security of our application, ensuring that only authenticated users can access our services, that is a user service and also our weather service. We are going to enhance our gateway even further by introducing caching, load balancing, rate limiting, and request aggregation. These features are essential for building scalable, efficient, and reliable microservices architectures. Let's get started. First, let's talk about caching. Imagine you have an e-commerce application and users frequently access product details. Without caching, every request would hit your database, causing unnecessary load and increased response times. By implementing caching in Ocelot, we can store frequently requested data temporarily, reducing database load and significantly improving response times. So let's configure Cache Manager to handle this efficiently. So before we install a package and we try to configure or add this caching service, let's introduce delay in all our requests. You can see from the previous solution that we created, we have two services in a microservice together with the gateway. So we have this, we have identity service in here, and we also have weather service. That is these two services. So in that, let's introduce, let's introduce delay. So in the controller, where we have this user controller, this returns just a list of users in here, a very simple one. But with this, we want to introduce delay. So let's say this await task delay. Let's delay 4 seconds. And let's set this to task. Okay. Now let's do same to, so let's grab this. Let's go to our weather forecast. And now in our controller, let's also introduce same delay. So we have our, should be here, async tags of action results. And now we can introduce delay. Let's make this also 4 seconds, and we need to return OK with this. So anytime that we make an API call to this, it's going to delay for 4 seconds each. Let's say, so we're going to run this project. So I'm going to right click on. Let's start with that gateway. Then we're going to also run our identity and also the weather forecast. So our weather forecast is this. Let's run this. And also we're going to run identity as well. So the weather forecast, that is identity, debug. Maybe we need to wait for this to start. It's not starting. Alright, so we have our API, there's a gateway ready now. Now our weather forecast also ready. Now let's go ahead and start the identity. Now I have Postman in here. Now we know our API or our gateway, if I put this out, our gateway is on 7000. So let's have that as a port of this 7000. And in here we have API and a user as an endpoint. Now if user endpoint is loading or if it is ready, as soon as we click on get, we must get user in here. Let's wait and see. Alright, so you can see that we have the content of the record in here. We can also specify or check for weather forecast. And we must also have the list of weather forecast. So we have the weather forecast list in here. Alright, so bear in mind that we have a token added to the header before we can get this. Good, now you can see there is delay in it, because when you check the seconds or the time that it took, 5 seconds and 0.5 milliseconds, right? Now if I click on it again, it is taking the same 5 seconds because we did introduce 4 seconds in it, and you can see we have 4.41. So at the time it's going to exceed 4. So at the time it's going to take, let's say, 4 minutes, no, 4 seconds to get this content for us. So let's introduce caching, and now let's see how this is going to retrieval will be faster than this. Let's go to our project, and now in here, before we do that, we need to install a package. Let's put this package in the gateway. So I click on dependencies. We need to stop this first. So right click on dependencies, manage NuGet packages. And now in here, let's install caching. So we need ocelot.caching. So ocelot.cache manager, we need to install this package. So click on install. Alright, so we have this package installed. The next thing that we're going to do here is we need to add a service. So let's go to the program.cs file. So from our gateway, you go to the program.cs file. Now let's add the service in here. So in here, where we have this beta.services.add ocelot, we're going to add cache manager. So maybe we need to, let's include the namespace first. So that is using ocelot. dot cache. Then we can add cache manager. Okay, then in here we can say that add ocelot dot add cache manager. We have this. Now we can specify some option, and we're gonna say option dot with dictionary handle. So there is only service that we need to add. Okay, so let's go to our API. Now the ocelot.json file that we created, so we can add caching to each of the controller that we have in here. Now there's an user and we have a weather forecast. So let's add caching to each. Now in order for us to add the caching, all that we need to do here is to specify another option, and I'll name it as file cache options. So file cache options. And now with this file cache options, we can specify the time that it should take, and it is TT. So you have TT seconds, and now we can specify maybe 60 seconds in here. Aside from that, so our cache is going to last for 60 seconds before it gets cleared off. We can specify the region, and now let's set this to default, and let's specify header. So this is our header, and now with this header, maybe we can specify caching control. Okay, so ocelot caching control, and enable content hashing. Let's set this to false. So enable content hashing, and let's set this to false. So that is all that we need to do. So let's go and let's grab this, and now we are navigating to our weather forecast, and in here you have a user, you have a weather forecast. So down here let's paste our caching as well. So the responses coming from these two endpoints, we are caching them for 60 seconds each. Great. Now we have this. Let's go and run this. So in order for us to run this app faster than what you've been doing, we can use terminal to do that, and just launch your window PowerShell. I have 3 tabs open, and in that I've navigated to each of the project. So if you have gateway, we have the weather project, and this identity project. Okay, so in that, in order for us to run it, we know the port of this. Example here is we know that the user identity here is running on port 7001. So that's what I'm going to do, .NET run, then --URLs, and now in here, it is running on HTTP. So all that I need to do here is to specify 7001, and now this is going to build the project, and now start that. We can also do same to this one. Now this also running. Let's see. So this is also running on, and that is the weather forecast. Weather forecast is running on. Let's check this out. 7002. So let me make it 7002. Let's also run this. Now you can see this is still building, and now this also building the project again. So let's wait for this project to get run. Then we're going to run our gateway as well, so we can test our caching. That's great. So you can see that they are ready. This is also ready. Now let's test the caching itself, and now this gateway is also running on 7000, but this is running on HTTPS. Okay, HTTPS. Let's say this is running on HTTP. Okay, this HTTPS should be HTTP, so we can stop this. Now this should run on HTTP. Yes. This also should do the same, not on HTTPS. So let's cancel this. Now let's run this on HTTP. Okay. So we wait, and now this is going to run on HTTPS 7000 as a port. Let's also build this. So we see this is ready, run on this port of 2000, 7002, this 7001. If it finishes, then we're going to have 7000 on HTTPS. Great. Now we can put our browser, or maybe we can even minimize this, then bring our Postman. So let's wait and see if they are running. Now this set, this also set. Let's wait for our gateway API. This is also ready, so we can go ahead, bring our Postman, and I can see from here we want to access weather forecast. So it's going to take 4 seconds, 15 milliseconds. That's the normal time, isn't it? Let's click on it to get it once more, and it should take 4 point something milliseconds. Now the next request, since we have introduced caching, is going to take some milliseconds, not even seconds. So click on it and check it out. So you can see it took 50 milliseconds, right? Again, see, it took 45 milliseconds. It took 86 milliseconds. Now the same thing, 18 milliseconds. Now when the time exceeds 60 seconds, then it's going to go back, going to clear the content, and I'll make another API call. That is just going to elapse for 4 seconds and point milliseconds. Let's try this for a minute. Check it out. Maybe by now it's getting to a minute. Okay. 5 milliseconds. And I can see that it is getting data again because the time has elapsed and I took 4 seconds and 0.7 milliseconds. So you can see that is a very simple way of introducing caching in your gateway using the Ocelot. So the next one, let's talk about rate limiting. Suppose you have a public API that is prone to misuse or abuse by users sending too many requests in a short period of time. Rate limiting helps you control the number of requests a user can take or a user can make, protecting your services from potential overload and ensuring fair usage as well. So with Ocelot, we can easily set up our rate limiting in an easy way. Let's see how to set rate limiting to this. So let's specify this rate limiting against the endpoint that we have here. You can see that here we have user endpoint, weather forecast endpoint. These two endpoints are eligible for rate limiting. So let's see how to do it. Now we can specify that beneath this file cache option, that is a caching. So let's have a comma in there. And now in order to do it, we have to specify our rate limit option. And now in that, there are some sections that we need to configure here. The first thing that we need to talk about here, it is a client whitelist. What is client whitelist? It is actually an array containing the whitelisted client. So client listed here will be exempted from rate limiting. Whatever configuration that you're going to do here, these client IDs will be out. Currently, we want to apply this to all requests, all client. So let's have a client whitelist. And on this client whitelist, we set this to null. That's an empty list. So from that, let's have the next one. And that is a enable rate limiting. Let's set this to true. The next thing that we need to talk about here is maybe period. So period, this parameter defines the duration for which the limit is applicable, such as a second, minute, hour, or days. Okay, and we can specify that by using S for second, M for minute, H for hours, and now D for day. So let's specify the period. And now with this period, as soon as you reach the exact limit of requests, the excess occurs immediately. So let's see. So maybe this period, you want this to happen within 60 seconds. Okay. Now with this 60 seconds, let's what we're going to do here is we need to specify the period time span. So what is actually the period time span? In order for you to make another request, you must wait for this period time span duration to pass before making another request, else it will be blocked. So let's have a period time span, and now here the whole thing or the whole process is going to take 60 seconds, that is a minute. So within that minute, how many seconds do you want to wait for before we can process or we can start accepting another request? We want to specify maybe 5 seconds. Okay. Now with this, or maybe we can specify 5 or 6 seconds to be okay. Now aside from this, what are you going to talk about? The limit. So how many requests do you want to set within a 60 second? Let's make it 2 requests. This is what we need to do. Now once you have this, let's go and make a copy of this, and let's go to our weather forecast. Now let's paste it. So we have our rate limit configured. Now let's build this. So I'm going to open this. Now there's our gateway. Let me stop this. Then rerun to build this. Then let's check it out. Alright, so that's ready. Let's go out there and now check it using this Postman. So you can see from here we are having the same endpoint of weather forecast, and now this has a rate limiter applied, isn't it? Now let's execute the first end, and now we're going to have access to the content. Second one in here, the 2 as what exceeded. Now see the next one, you must have an API, that's the maximum attempt. So we can only make a 2 requests within 60 seconds, that is a minute. If I click on it, unless the 60 seconds is exceeded, it passed before we can have another request. So have a look. Now still gonna have it. So you can specify maybe I want 100 requests per a minute, I want 1000 requests per minute, and now when the request exceeds the number of limit that is specified, it's going to have a reject of the status code of 429, meaning too many requests as indicated here. So that's also a simple way to configure rate limiting Ocelot Gateway API. The next thing that we're going to talk about here is request aggregation. What actually is request aggregation? In a complex microservices environment, you might have scenarios where multiple services need to be called to fulfill a single request. For example, in maybe a social media application, fetching users' profile might involve calling separate services for user details, user posts, and maybe users' friends. So Ocelot request aggregation allows us to combine these multiple downstreams or these multiple endpoints or requests into a single response, simplifying client interaction and improving performance. So we're going to call 2 endpoints together and now display the results to the user. So just make one call and I have 2 results from 2 separate or individual endpoints. And this is available through Ocelot. Let's see how we can integrate this request aggregation. Before we can do this, we need to specify key. And now the key is going to be like a unique ID for that specific endpoint. The key is what we need in order to call that endpoint, because maybe you might have multiple endpoints in your Ocelot. Now, in order for it to be specific, that is the reason why you need to provide key for that. So let's see the keys or the endpoint that you want to aggregate them. Let's assign a unique key to each. So you want to call this weather forecast and user together. So in here, let's assign a key to this. We say this is key. Okay, so here we are having our key. So this must be key, not request ID. Okay, so this is our key. And now this key here, this is, so let's say this is user service, because this endpoint returns list of user. Let's give the same user key in here, and that is key. So this key, we are giving this as also weather forecast service. So we have two keys in here. Now let's call these two keys in our route. So in order to do that, you see from here, we can specify our own aggregation. So let's type in aggregation as aggregate. Okay, so with this aggregate, all that you need to do here is there's an array. So let's put comma so that we go to the next one. Now in this array, all that you need to specify here, it is a route keys. So we have our route keys. What are the keys? These are the keys that we provided. There's also an array. Now these are the keys that we provided, and at the first one here it is user service, and the next one we have what? Weather forecast service. Okay, so this you must have. Okay, so this is what we need to specify in here. We have a route key, and now in the route keys, this should be inside this. We must have one. You need to be careful when configuring this, else it's going to be an issue. Yes. Alright, so we have our first one in here. Then in that we are specifying our route keys, and now you want to join this together. So we have a user service and a weather forecast service, which directly represent user controller and a weather controller. So now that we have this, the next thing I'm going to do here is we need to specify what the user can, what external client can make access to. And now we need to specify an upstream. So that is, let's put it in the bracket. We say this is upstream path template. Now this upstream path template, what are we going to do in here? What URL can a client access to get this? We can say that this is /API/ let's say this is aggregate. Only this. So you want the client to make a request to this. And that is all that we need to do. Now we're going to run this, and I'm going to call to this endpoint. Okay, and now see whether we're going to have access to user and also weather forecast together. Let's save this. Let's go to our terminal. Now from this, let's stop this. Now let's run this again. Now we have this running. Let's go to our Postman, and instead of this, we're going to make it as aggregate. Now let's make a request. This should return 2 responses. Let's see. Great. So you can see from here we have a user service. The user service is returning the users in your netcode hub and our thread. Now weather forecast service are returning, this is the first record, second up to the number of records that we specified, 4 or 5. So you can see that here we can aggregate results. You can call 2 or multiple endpoints in here, and now the result is going to be 1. So we can extract them and now use them in various functions, or whatever thing that you want to do with them. You can go ahead, extract, and deal with it. So the last thing that we are going to talk about, it is a load balancing. When we say load balancing, what actually is it? Consider a scenario where your application experiences high traffic, such as during a flash sale. To ensure your system can handle the load, you need to distribute incoming requests across multiple instances of your microservices. Ocelot's load balancing feature allows us to do just that, ensuring high availability and reliability by preventing any single instance from being overwhelmed. So application that you have in here, we're going to create an instances with different ports. Now these instances, we're going to make Ocelot configure with them so that it's going to balance the load on them. It's going to share the load across. So not only single service, not only single instance going to handle all the requests from the client. Now we scale our application, we can implement this load balancing so that it does share the request coming from the client to these various instances. So that's what we need to do, and that's what load balancing is. Alright, so let's see how we can configure that as well. So in order for us to do that, we can go to our API endpoint, and now this endpoint in here, you can see we want to handle load balancing to this service, that is user service. So in this, what are we going to do? We're going to make a duplicate of this. There is the downstream host and ports. It is host and port, so it means you can handle 2 or more ports. Let's make a copy of this, and now let's make comma and paste this. Now let's change this port to, we have a last port of 7003, so we can have 7004, and now we can also copy one, and now let's say 7005. So we see from here we are making 3 instances of this application. So this application is going to run it 3 times, and after the 3 times we're going to make a request to this. Now with the type of load balancing that you're going to use, it's going to share it across each of the instance that has been created. So if I made 3 requests, the first one is going to be get it to respond, the next request will go to the second one, and the last response will come to the third one. If the new request comes in, then it's starting from the first one to the last one. So that's what it's doing, circulating. So it's going around, starting from the first one to the last one, and now it reverses it. So that's what it's going to do. Now, how do we run this? Let's first run. Since we've added this, we need to run. But before we do that, we need to add the load balancer option, and this can be added down here. So let's say this is load balancer option. Now this load balancer, let's set up the option. So aside from having this, we want to specify this must be, and then here we need to specify a type. So I think there are 3 types: round robin, list connection. So let's use the list connection. So as I said earlier on, it's going to start from the first one, assign the next request to the next one until all the requests have all the instances, they have requests each. Then it will start again. So that is what this list connection is going to do as a type. Great. So now that we have this set and configured, we can save this, and let's go to our terminal. Let's stop this. Let's start this again, and I know that this is running. There is a user. It is already running on 7001, and when you check here, we have made extra 2 configurations, that is 7004, 7005. When you check authentication, let's see which port is this authentication using. So you want to conflict it in here. Authentication to the launch settings. This is using 7003. Okay, 7003. So when you go to our Ocelot, we can use 704 and now 5. Great. Let's check and see. Now this is running. Let's open another tab. So since this is running on 7001, let's make this run on 7004. And in order to do that, we're going to have a look at this. So let's use .NET Run because we've read it already. So .NET Run. Then in order for it to, let me increase it a bit. In order for it to run, we need to specify URLs. And with this URL, let's make it sense. Now this running on HTTP, right? So with this, we're going to say that it is localhost. Then the port here is 7004. So this is what you want it to run on, right? So we have this. Now it is running on .NET. We have our run -- URLs, and here we are specifying HTTP / localhost and then the port, that is 7004. So it is going to build this and it's going to run an instance of our user endpoint. Now let's do same in here. So we can have .NET Run -- URLs, and in here HTTP. Then this is localhost port 7005. That is this one. And here let's also run this instance. So here we are having 3 instances running. Now we can access it straight from here. Now in order to access it, let's wait for the last one to get run, then we check it out. So we have this ready, this also ready. Now this is not ready yet, so let's wait. This is also ready, 7005. Let's go to our Postman, but before we do that, I want us to, let's have our console. So this is going to be the console. So we're going to watch here. Now if a request is made from this instance, we're going to have it down here. If it's made from this instance, we're going to have it in here. And if it is made from this instance, the 7001, we're going to have it in here. So let's start by, let me put this here. So maybe I can, this is the first one, and I can have it. Okay, then we have the next one. Let's also bring this here. Then there's going to be the last one. Let me minimize this. Then let me also do this. Okay, now this is our endpoint. So we're going to make our API call to this. Now if I click on this, let's watch and see what's going to happen. So this is user. We have first, so we are going to make a first API call, right? If I click on this, let's wait. It's going to go through the Ocelot, and let's wait and see which endpoint is going to get hit. Now we have the first one retrieved from here, and now with this, we are not getting any response here. Okay, so maybe this is what I am going to do. Let's go to, this is, yes, so we have it in here. So you can see all the requests that we have made, we have them in here. Now let's go in there and now check the API endpoint that, or the instance that it got this request from. So first of all, let me just open this, right? Now starting from here, so this is our API endpoint, API 7000. Now this is the first call that we made, and we made this call to an API/user. And now with this call that we made, do you have any address? Do you have any port specified? Let's go through and check. Yes, I think we can find it from here. Like we see, the first one is making an endpoint from, that is, do you have it? Yes. So because you have 7001, and that's the first API call that it made. The second one was made to 7004. So you can see that it is not repeated, but rather it has moved to the next one. And now the last one, we have 7004. The next API call made to 7001. You see? Now let's try to make another call again. So make another call. And now this call was made to, let's see, 7005. So you can see that we have 7005 in here, 7001 in here, and now we have 7004. If I make another request, now this request, let's see, the first one was 5 currently, and now it's going to 7001. Another request, and 7001, let's see another request, 7001, the next request, 7005. So we see now it is balancing the load for us. So it gives you 7001 instance. When that instance is done, the next request given to 7004 or 7005 is going to share it among the instance that we have created. So by doing this, we can now balance the request or balance the load, and now you do not overwhelm one instance with the whole request. So by implementing caching, load balancing, rate limiting, and request aggregation in our Ocelot Gateway API, we've made our microservices architecture more robust, scalable, and efficient. These features not only enhance performance and reliability, but also ensure a smoother experience for our users. I hope you found this tutorial helpful. If you did, don't forget to like, share, and subscribe to the Netcode Hub channel for more exciting content on .NET and microservices.